Well done for making it through section 1. 3D can be quite intimidating, but I hope to make the process of learning to use the ThreeJS library as easy and fun as possible. Whether you want to create a visualization for a science website or the next big online game, you still need to start with the basics. You've learned that creating something we can see on screen is a two-stage process. We create some geometry and we create a material, and we use these assets to create a mesh that we can add to our scene. We've already looked at creating a box using the ThreeJS library, but let's build on that to see if we can create a simple tower. For the video I'm going to use CodePen so you can see the results straight away, but you can use the resources and web server for Chrome if you prefer. To get started, shoot along to this address. In this ThreeJS template, I've already created a ThreeJS scene, added a hemisphere light, a directional light, and positioned the camera at a useful position for the project we're going to develop. Using the update function, the screen should update every 60th of a second. I've also added something called orbit controls. This allows us to rotate around a defined point simply by dragging the mouse or using a touch device. We'll use this template as the basis for most of the web apps that we develop from now on in the course. The template is also available in the resources. Just look at section 2. We'll be looking in much more detail at lighting later in the course. In this video we're just going to focus on creating boxes. To create a tower, we need to stack boxes on top of each other. First we'll create some geometry. Can you recall the way we do that? Yes, you use const geometry equals new 3.boxGeometry. We're going to make our boxes 3 units wide, 0.4 units tall and 0.9 units deep. But we're going to use a variable for the height, so enter const height equals 0.4 just before the geometry assignment and change the 0.4 parameter to height. Great! Now we need a material. Enter const material equals new 3 mesh Lambert material. Then you enter an options object. An object in JavaScript is contained inside curly braces. Here we're using open curly brace color colon 0x DCBBC7. We can actually pass a hexadecimal value. Hexadecimal values in JavaScript are preceded by 0x, so the compiler knows how to use them. Mesh Lambert material is the simplest material that uses lighting. It is good for matte surfaces, but not great for shiny surfaces. But it is the material with the best performance, and you should always aim to use the material that suits the mesh you're displaying while offering the best performance for users. We'll look in more detail at materials later in this section. Can you recall how to use the two objects we've just created to create something we can add to our scene? Pause the video and have a go yourself at creating a box object and see if you can see it on the screen. How did you do? Just use const mesh equals new 3.mesh geometry, comma, material. Then add this to your scene using scene.add mesh. So far so good. But we want to build a tower. We need a loop. Comment out the line where you add the mesh to your scene. We're not going to add this one. We're going to use it as an object to clone. That is to make a copy of. Enter for open bracket let row equals 0 semicolon row less than 20 semicolon row plus plus close bracket open curly braces. Inside the curly braces enter for let count equals 0 count less than 3 count plus plus. We're going to have 3 blocks in each row. The center of the original mesh is at 0, 0, 0. We want to position our blocks like a Jenga pile. We need a Y position for each row. Before the second for loop, enter let ypos equal row times height plus 0.05. In a Jenga pile, the blocks are positioned at right angles to the row below, usually in sets of 3. So we need to rotate the blocks and then position them by moving them in either the X or Y directions depending on the rotation. We'll use another variable to contain this value, initializing it to -1. We'll call it offset. Enter const block equal mesh.clone scene.add block offset ++. If curly braces, end curly braces, else curly braces. Row %2 is a simple test for odd and even. The modulus operator, % gives the remainder after dividing by the right hand side. So when row equals 2, for example, the result is 0, or false when used in an if condition. Whereas if row equals 3, then row modulus 2 equals 1, which is true. Anything other than 0 is true in a condition statement. We now have the ability to position the even and odd row differently. For the even rows, we simply position the block at 0 ypos offset. The first block in a row is positioned at z equals -1, then the second at z equals 0, and the third at z equals 1. For the odd rows, it's slightly more difficult. We also need to rotate the block 90 degrees in the y-axis. Rotation in ThreeJS is measured in radians. There are 2 pi radians in a complete revolution. Pi is about 3.1415, so a complete revolution in radians is about 6.283. 90 degrees is a quarter of a revolution, or half pi. So we set the rotation.y value for the block to math.pi divided by 2. Now we need to position the block so it's at offset ypos 0 and increase the x value by 1 for each block in the row. And there we have a Jenga tower. I recommend keep pausing the video and working along with the code. That way you're much more likely to remember the steps needed to really get to grips with this great library. A complete version is in the resources and on CodePen at this address. This video comes from my Packt course. Find the course on Udemy by following the links in the description.